Good morning and welcome. Today, of course, we are going to give you guys a quick update on the standards. So it's exciting stuff. There are a couple of things we've just got to run through quickly before we get carried away. There are two things happening: an update on the standards, and then we've got the prize giving of the hybrid competition. So we've had quite a lot of sponsors. It was Anton's initiative. He's put a lot of work into it, and it's been a great initiative. So thank you very much for everybody joining us. We had just over 200 guys who registered for the webinar, and I'm thinking that we should have about 150 guys at the peak of the webinar signing in. I would like to just share my screen quickly. There's a presentation that I'd like to cover. You guys should be able to see it. Please use the chat box for raising questions. Please switch off your video to preserve bandwidth. The recorded video is going to be uploaded to the Arab YouTube channel. So you guys should be able to see it there. And then you've got the option to pin the presenter to the screen. So guys, if you right click on the photo of the guy that's presenting, you should in fact see a small image of me on the one side of the screen, and you should see my presentation on the other side. So there are lots of different things you can do with the Zoom platform. So Alexis is up next. He's quickly going to give us the update on the SANS 10313. So as installers, we are very focused on 10142 part 1, which is of course the wiring code. But there are other standards that are applicable that have also been updated and that the guys are working on in the background. So I'll be doing the presentation on SANS 10142 part 1, part 2, which is the solar standard. Alexis is going to be doing the presentation on 10313. And then Anton will be participating in the prize giving. And Anton is going to handle the prize giving. And then towards the end of the presentation, Greg Blandford will quickly do the closing and thanks. So that's kind of the lowdown on the program for the morning. I think, Alexis, if you are ready, you are welcome to start up.
Okay, goedemorgen, good morning, everyone. Always a privilege to talk about lightning because we are what is called Serenophiles, and most people think we are the crazy ones because we love lightning and thunder, and we are considered crazy because we might be running around outside during lightning storms, trying to take these beautiful images that lightning does give. However, we love having these sessions because we also need to share with everyone how dangerous lightning is, how much it affects our systems, especially nowadays that systems are becoming more and more electronically based, as solar is. And
sorry, Alexis.
Hi.
Alexis, are you sharing your screen? Because we can't see your screen.
So as I was saying, thank you very much. I also got a comment that we are a little softer. I'm going to speak into the mic a little more. I hope it's better. The interesting part that I will share with you later on is that the underwriters are actually seeing a majority of damages to being caused by either a lightning-induced surge transient, a lightning strike itself, or a power surge coming through the system when normally you have things like load shedding. And so when we see that the underwriters are in fact acknowledging that lightning or transients are one of the 3 biggest causes for damages, we have seen a massive swing in the market where once an EPC or a funder is getting involved to try and get a project over the finishing line, lightning always comes up as a topic. And one of the key things, and you'll see it as well in the standard, is has the assessment been done? So has the risk been assessed? And then based on the assessment of that risk, what mitigations have been put into place to protect the asset, to protect the funder, to protect also the EPC. And I'm going to today share with you what has been done from the Bureau of Standards side. So I failed to introduce myself. Apologies for that. My name's Alexis Barwise. I am a lightning protection consultant. I'm the chairman of the Lightning Protection Working Group and also represent our country at the IEC level on the lightning protection codes. What I'm going to share with you today is just a very simple guideline that we have built at the Bureau side in order to give you at least an understanding as to what should be done next, what is the path that one has to go down, and then how does the standards actually lead us if we are not, example, lightning protection experts. And we start by your wiring code, so the SANS 10142, Part 1, Part 2, Embedded Generation. And you'll see that in 5.4.6 is the first normative reference given about lightning protection. And the most important part is line number 1, which says that the lightning protection, which is both an internal and an external, right, system, shall be done in accordance with the SANS 10313, which is the local lightning protection standard, and also in accordance with SANS 62305, which is the adopted IEC standard, Part 1, or we give 5, call it, go-to things that will always help a system in terms of the effect that a lightning surge or transient have. And these include the following: to keep your DC cable runs as short as practically possible. I think that's in any case a given. I know that these things are costly as well. However, it is still, we see on when or there's a couple of strange levels that the guys are following quite long DC cable runs. Another interesting part, which we are really trying to advocate, is that if ever possible, try and always keep the DC cables inside metal ducting, metal trunking, a metal wireway that's at least covered to 80% by steel and only leaving 20% air. Putting it into like a wire basket that's more air than steel is not. So we've got to try and get these things into like galvanized conduits, into what's quite common on the rooftops are these metal ducting. So there's like a cable tray with a lid on top. And the simple reason is it builds a cage. Everyone knows Faraday's cage as a concept, but it builds a cage which shields your DC system or even your RS-485 communication system from the induced lightning effects that would be present on a solar system. The second or the third item is to keep the cables right alongside one another in order to limit the loop that is created. Now, again, this is quite an interesting one. We've had many sessions with the big EPC saying from a solar side, it's easier to just run a positive all the way through and then bring one negative back, and you end up making long loops. But we are advising again that the shorter we can keep the loop, so the loop is the area between the pos and the neg multiplied, obviously. So area is the length times width. So the width would be that spacing in between, and the length would be the length that these parallel conductors are running. The longer that the loop, or the larger the loop, the larger the effect of a transient, an induced lightning current or an induced lightning strike would have. So it's almost like exciting, so creating the higher over voltages. Hence why it's a good practice to keep these cables alongside one another. The last part, the last 2 points, is to then do bonding conductors along the PV system. Very big topic we've had in the 10142, because it gets quite tricky when we do bonding from an electrical point of view. We are able to do bonding with, example, a 2.5 mil squared cable. Yet when we start doing purposeful bonding for lightning protection, reasons, then we actually have to upgrade that to a 6 mil squared when we do not consider direct lightning strikes, and to 16 mil squared when we consider direct lightning strikes. And I'll show you that in the 10313 standard in a few seconds. And the last part is to then fit the correct surge protection devices, so that they have to be correctly selected and also installed. And there's a drawing given in in this standard, and I'll show that to you just now. Interesting part about the surge protection as well is that we have made it a mandatory item that a surge protection device be installed on the DC side of embedded generators. So that's not even a choice. You have to do that, but you have to also understand which one to use. And I'm going to show you in the drawing. Here we go. So we are updating this drawing now since our meeting a week ago, but in essence, you can see that we've got a surge protection device here on the DC side. If you can follow my mouse, there will then also be a surge protection device on the AC side of the inverter. And even at times, there will be a surge protection device if needed at the point of supply or point of control. If needed is dependent on the risk assessment that will be done. And so let me show you how we are assisting in 10313, the lightning protection standard. So I'm just going to open that one specifically. Okay, can you confirm that we can see 4.3 PV systems, less 1 MVA?
Yes, we can see it.
Okay, here we say that the risk assessment for PV systems can be done in two ways, depending on the agreement between the customer and the supplier. And we are stating that because one could be a complete risk analysis, right? Or it could be the other way around, where we see people accept a residual value. So a risk per year, you've got to prove that you're at least below that value. And so what we have done here is we have then looked at multiple risk assessments. We ran hundreds of models, and we came up with a matrix to give you a guidance, at least as to when do I even need to do risk assessment. And so here we have followed your categories of part 1, part 2. So category A1, category A2, and A3. And then we have a low, medium, high, and severe lightning ground flash density value, which can be obtained from the Weather Service, also from both these standards. It will be published in the annexure sections. So we will now say category A1 would be a home, as an example. And if we build a home in an area above 11, example, the Drakensberg, or perhaps in Johannesburg would be one as well, it is then advised, not mandated, not required. It is advised that it would make sense for you to consider it because you are in a severe lightning density area. When we look at the most common systems nowadays, these category A2 and an A3s, now we start seeing in areas like Cape Town, it's still not required because we understand the risk in Cape Town, and because 10142 part 1, part 2 mandates the SPD on the DC side, plus asks you to do shielding of cables. This is in any case already enough in terms of mitigating the risks for low lightning areas. And when we get to a lightning flash density above 7, so the likes of Bloemfontein, the Bijl, these areas, Heilbron, then all the way to 11, which is Pretoria, so that would be those values. Then you start seeing mandated, so it is an absolute requirement that a risk assessment be done at the time of the design, at the time of the execution of the project. When we move to category A3, above 100, below a MVA AC, we have, again, at 0 to 3, so Cape Town, Stellenbosch, these areas, it would be an advised item, even like Port Elizabeth, this is also at around 1. So it's advised to do it, but it is not required. But above 3, already there we see that these large systems, it's definitely mandated to do it, because we find also that these systems are obviously being placed on rooftops, making them also the most exposed point when lightning is in fact reaching down to earth. Now, what is an interesting item which we have added is that very often when you are installing a embedded generator or a solar system on a mall, for instance, and let's call it an 800 kVA in Pretoria, and we're sitting at this area here where it's mandated, we have a very nice, yeah, what's the right, but a very nice way to also obtain the risk, because what we know is the buildings themselves have to have done a lightning risk assessment based on 62305 standard part 2, where they should have already ascertained the risk of things like the occupants, human life risks for themselves, for the mall. If you have a customer who has done the risk assessment and we have those values, it is a nice way to obtain the solar risk, is to say the risk of the solar is equal to the risk of the building, so the risk assessment that's been done, multiplied by the area that the solar takes up of the area that the building is. And so it's a very nice way to just get to a risk factor for solar, because, and we write it very clearly here, and don't let anyone else tell you otherwise, the erection of PV on top of a building does not increase the frequency of lightning strikes to that building. That is hogwash. What it does do is it brings a different type of risk to the building, which was not there before. Risk like DC arcing, risks like fire starting, risk like loss of economic impact, in the sense that the actual generator is not generating any revenue. But it does not make or attract the lightning. That is not true. We have a very clear statement here to say that if the PV system does not protrude more than 0.5 meters above the building, then the effect of that PV in terms of the frequency of lightning is absolutely zero. Okay, so that's quite a nice thing to see, because we find often that we have the risk assessment of the buildings at hand when we do the risk assessment of the solar. I will move on and show you also in part in order 3 how we have also helped in terms of the selection of bonding conductors, as I said earlier. So if you are doing the earthing connection, so the bonding conductors, if it's copper, 16 mil squared when considering lightning currents. We're not considering lightning currents, a 6 mil squared when it's copper. Aluminium just obviously size up. And even here on the SPPs, if you're installing a type 1, it will be a 16 mil squared. And if you're installing a type 2, again, a 6 mil, because type 2s are taking care of induced lightning, so just not direct strikes. Okay, moving on. We want to get to the point where we show you the examples. So that's a bit of fetch. Here we go. We have in the standard prescribed 2 methods, which we are recommending to people or any EPC, obviously based on the roof itself, is mostly the driver. So first of all, it's important to note that nothing less than a lightning protection level 3 system will be accepted for PV, and that isolated lightning protection systems are the preferred method. It's not wrong to do bonding. In fact, you cannot sometimes not do a bonded system, but an isolated would be the best, because then we are keeping the lightning currents, the actual direct lightning currents, away from the entire embedded generator. Here you can see an example of it. I'll zoom in a little bit more. Maybe I can just close that. So you can see that there is a mast placed adjacent to the panels, and you can see these masts are all adjacent to the panels. Definitely an option on concrete type buildings with parapets, where we've done one example. Wits University looks very, very similar to this. And in this sense, what's going to happen is lightning will strike the mast. It will then go to the reinforced concrete, and the reinforced concrete will then, we will test the continuity down to earth, and that will then take the lightning currents down to the earthing system. Then we only have to deal with the induced effect that strike would have on the PV system, and that's when we will start doing, as you can see, the bonding here, but the bonding will be done by a 6 mil squared, because it's not carrying any lightning currents. When we look at a bonded system is when we have a physical connection. You can see here a physical air termination rod. Bonded systems are predominantly on IBR sheeted roofs. We see them so much these days, where you cannot, physically separate the lightning protection system from the from the PV system. It's all bonded together. This is still acceptable, nothing wrong with that. The only difference is now we will have to bond with higher or bigger sized cables in order to carry obviously the bigger sized lightning currents. We have a question from Sherrat Victorious asking if an inverter's integrated surge protection is acceptable. So yes, absolutely. Sherrat, yes, that is acceptable. What is interesting is just that one has to check when you have a bonded lightning protection system, and I'm coming to that, one would have to have a type 1 and a type 2 combined surge protection unit, where normal inverters, default, they would come out with a type 2 only. So you'd have to upgrade that selection. If it's an isolated lightning protection system, you can live with a type 2 only. And here you can see the drawing again. So from the DC side, there will be a DC SPD. On the AC side of the inverter, an AC SPD. If that length of cabling is long enough, so that's where the risk assessment comes in, then we would also put an SPD at the grid connection, because we're also trying to stop any of the ESCOM switching surges, switching transients, to not affect the inverter from the AC side. So in most cases, you only have one, either number 2 or 3. On longer installations where the grid connection and the inverters are far apart, you would have both of those. Here you can see a very nice table. The table gives us, if we are installing SPDs in a structure and we do not have any lightning protection, so we don't even consider lightning protection, a perfect example would be a home application. So not even considering external lightning protection, then we see SPD 1, so on the DC side, would only be a type 2. So that's the question of Sherrat earlier. Minimum 10 kA. SPD 2 would be, again, also type 2 because we're not dealing with lightning currents. And there the minimum would be a 20 kA because obviously this is an AC arrestor. And again, on the SPD 3, the same. Now, if we look at installing an SPD in a structure with a bonded lightning protection system, so i.e. everything's connected, so the system, the DC system, will be subjected to partial direct lightning currents. So we cannot maintain the separation distance. Then you see very clearly comes the requirement that we need a type 1 on the DC side, and type 1 on the AC side, and then combine it with the type 2, because the type 1 takes care of the direct lightning strikes and the direct lightning currents, where the type 2 takes care of the induced transients and power surges. So there would be then your selection. You would then have to upgrade your inverter to incorporate these. And then finally, if you have installed the surge protection device in a structure with an isolated lightning protection system, which is the preferred method, right? Again, we only can install type 2s, which are default SPDs inside the inverters.
Alexis, my apologies for the interruption. I see Kobus has a question, but just before we jump through to Kobus's question, I think it's just time for a quick commercial break. I'd like to give Scott from Get Off Grid just a minute or two to quickly do his presentation, and then we can get back to answer Kobus's question.
Hi guys, my name is Scott Andrew from the company Get Off Grid. I'd like to start off by saying congratulations to all the winners. Get Off Grid and Victron are really proud to be associated with this competition. We hope that it will inspire more of you to do Victron systems in the near future. Get Off Grid has become Victron's largest distributor in Africa, and we specialize in servicing the trade sector. We're proud of the product, and as a service partner with Victron, we know we can always provide you, the installer, with the very best pricing, backup support, and training. If you're considering a Victron system and feel like you need some help, please feel free to make contact with us. All the best, Scott.
Scott, thank you very much. Alexis, the floor is yours. We can quickly get back to Kobus's question.
Kobus van Tonder, Moro Kobus, when will SANS 10313 come into effect and be available on the SANS web store? When I can get my working group to sign off. So we have reached a working group draft stage. So we are working through our own internal comments, which should take another meeting. So I would say mid-July. You would probably, as a market, you can expect end of July, end of August, where am I? End of August, a draft will be sent to the public for commenting. We will share it with Arab, and I think then from your side, Carel, you would then share it with your members. I think that would be you are in any case part of the working group, so you would get that document, and then we will circulate it to the public for your comments, and we then are given another month to work through. So you have a month to answer, and then we have a month to work through your comments. And if we reach that stage, we hope to have the document printed, so accepted and adopted by end of November, early December. Happy? Okay, I can carry on. So then there is the maintenance inspection of lightning protection systems. Always a topic, always a question that is coming up, is to say how often, what must we look at, what is the, who should be doing it, etc. So we have a very clear section about the inspection, what needs to be inspected and commented on, SPDs, etc., connections from the lightning system, testing of the earthing system itself. And here you can see again a guideline. Depending on the lightning ground flash density, the months would then vary in terms of when a maintenance test should occur. And so you can see here that for areas below 3, every 2 years would be acceptable. And for areas above 3, we would have every year a lightning maintenance test certification done. The certificate that you will receive, which is an addendum, and I think this is really important that everyone understands this. In your 10142 part 1, part 2, you have your own test reports, right, that are addendums or annexures to the actual certificate of compliance. And the lightning certificates are exactly the same. They are test reports, which are attesting to what's been done, which forms part of the actual COC that will be submitted in the end. So now you can see here that we would have a lightning ground flash density value, which purpose was the use for, what type of roof is being used, and you would sign it off by the designer, by the installer of the lightning protection system, and finally, to close the loop, by the actual registered person. So the installation electrician, he would then also co-sign the COC number, and that would then obviously close the gap. And this is the safety report that you would then attach to your COCs. There are multiple other pages to it, which attest to the details, which is just filling in what size of surge protection you used, what size of conductor was used as the bonding conductor. Did you do the earthing test as an example? What was the earthing test results? Did you have an instrument that is calibrated? So you can go through this when the standard is shared with you. I just thought it was interesting to show you what it would look like, especially also when we get here to the DC surge protection devices. The questions will be asked. Is it a compliant device that was used? What type it was, the ratings, and if it has been installed. We have 2 more questions. Eugene just said greetings, so I can dismiss that one. Kobus, you're asking who's deemed competent for lightning protection system design according to legislation? So very good question. Right now, there is no registered person like with the electricians. We do not have a body or a Department of Labor that is certifying a trade in terms of lightning protection systems. The definition in the standard, I can show you that quickly right at the beginning. It's a self-declaration, because you become part of at the end, the one who's the ultimate responsibility is the registered person, which is signing off the actual COC. So here you can see LPS designer is a person who is competent to design an LPS based on their training, their knowledge, and their experience, as well as the knowledge of the relevant standards. And we brought that in with a very for a very particular reason, is that people that have been doing lightning protection via freestanding masts for the thatch industry cannot just all of a sudden run onto a PV roof and start doing PV lightning protection. So one's got to have an understanding of the relevant standards. So I think there you would have to look at someone's bio or his recognition of projects he's done, perhaps also his training that he has obtained from the market. An installer is exactly the same definition, only that he cannot design, he can only install or construct. And then an inspector would be someone who can test and inspect the lightning protection system, right, based on their training, so same methodology, but note it is recommended that an inspector is in fact a registered person of the Department of Labor. So we are really trying to help the electrical market also, the installation electricians, to a point to say, you know how to test, you know how to do bonding tests, you know how to do an earth loop impedance test. You then can actually be trained and get to a point, and Arab is actually running a training session, which we are joining with, is to train people up to be at the point where they can test and inspect lightning protection systems, not necessarily install them. So that is the definition, Quibus. But the answer is, so there is no adoption yet legally. Legally still only the registered person stays ultimately responsible. Okay, hope that answers your question. Now I go back to, I wanted to show you an example of the designs and more detail of the PV. So we've given you examples. So we're putting a new lightning ground flash density map in for you as well. And here we go. I just must turn this. So here you can see an example of an isolated lightning protection system for PV. And we've given quite a clear, methodology to this. So we isolate by the mast, we run the rolling sphere, making sure that we, in fact, protect the entire solar system. Then we need only a 6 mil squared copper conductor, as we said earlier, because we're only dealing with induced surges. And then the SPDs to be fitted. You can see that there's a clear guideline to a type 1 has a lightning strike in it, the type 2 only has a triangle. And you can see here we would only require type 2 SPDs on the DC and AC side of the inverter, and the type 1 on the main DB, because we still don't know what ESCOM could be bringing in from the other side. But a main DB type 1, type 2 combination is already quite a standard practice. In the same breath, if we look at the these bonded systems, so something like an IBR sheeted roof, again, we would have the masts up, but everything will be interconnected, obviously, because it's a one bonded roof. Then we would upgrade the copper conductor to 16 mil squared and the SPDs to type 1, type 2s. And you can see also by this bonded LPS drawing, which will also be given to you. And then finally, for a house application, so where we don't have any, where is it now? We don't have any lightning protection system, which is also an option, only surge protection. So there's the copper conductor, 6 mil squared is the minimum, DC side SPD, and that is your typical home application. Okay. We've given a nice rolling sphere table to help people, also a nice angle method table to help you place the air terminals. What I've realized, not discussed, is the last part is the shadowing. So we made it a very clear statement. So there is so many topics out there, or so many, I would say, philosophies to date. Even from Carel's side, we've done our own studies. We have no real factor formula or a bankable method to say if there are shadows because of clouds or lightning rods or whatever it may be. So diffuse shadow, so a shadow line that moves, that is far away, what the effect of the effect it'll have on the performance ratio. So that is still unclear today. Everyone thinks it does have, but we don't have actual results. or actual formulas to work that out. What we do have, and what we are stating very clearly in the standard, is that we know that the core shadow, meaning if a lightning rod is too close to the panel and its dark line, the dark shadow is being casted onto the solar panel, when it hits one of the blocks, it actually heats up that block. It creates a hot spot. We have recorded in the field over 90 degrees Celsius. Carel, you mentioned the other day you had 102 or 104 degrees Celsius one because of a core shadow line.
Yeah,
and
it
so
was 115.
115, wow. So what we are clearly stating here is that the core shadows shall be avoided at all cost. So we will not accept a lightning protection system where the core shadow is throwing, where there are core shadows on the solar system, which will cause hotspots and damage the actual system. Okay. So let me see, that covers this part. That is been covered. That's it, Carel. So I'm happy. I take any questions now. That was a summary to show everyone just how we've tried to guide, the lightning protection requirement. And it really all starts with the risk assessment. And it starts with this table that says, when does it make sense to do a risk assessment? And when is it actually needed, an actual requirement? I open the floor for questions. How many minutes do we have left, Carel?
Alexis, you are actually spot on as far as timing's concerned. So your slot was up until about 22. If there are yeah, that's excellent. Thank you very much. If there are a couple of questions, it'll be great to answer them. I just see that Kobus had another question where he said, what avenues are available to get trained for LPS design? But I think you've answered that. I don't know how extensively though.
So as I said, yes, Carel, so together with Arab, we offer a training module on lightning protection systems from a design point of view. It's a day course which you can attend. Also, I think you incorporated it into the P4 platform. Carel, if I just confirm, I'm not sure if that's done yet.
Yes. Yes.
Okay.
Sections of it has been incorporated into the level 2 test, and I know that there might be some guys waiting for their links to the level 2 test, but yeah, we have completed the level 2 tests. We are just supposed to share the links.
So I'm going to just show everyone quickly that part. So the Lightning and Solar unit is built for exactly this purpose. Learn how to do the risk assessment, how to design a safe and effective LPS, get the updates from the South African Bureau of Standards. It is presented by myself and my partner, Trevor Mannes. We are lightning protection consultants. So this would be one definite avenue, Kobus, is to either do it through the Arrow platform. Also from our point of view as LPC, we also offer our own training where it's also driven towards other industries, not just solar, but example, normal buildings, etc. Again, these modules can be taken from our lightning protection college, or we can set up a session directly for your company.
Excellent. Alexis, thank you very much. You guys, as part of the sponsors for the hybrid competition, had a 3-minute marketing slot, and I think I think you've just taken it up.
Richard Edwards asked if you have to join the electrical main earth to the solar earth. So Richard, that is a question actually more towards the wiring code, and the answer is absolutely. So yes, one has to bond those two together.
We've got one more question from Werner and a last question from Anton. So I think we've got 2 questions, and then we've got to move on to Anton so that he can quickly do the prize giving of the first part of the competition.
On the DC side, would it not be better to the SPD closer to the PV array with a dedicated earth spike rather than to have it closer to the inverter where it is bonded to the earthing of the dwelling? So good questions. Again, it depends on that length of cable between these two. So you'll see when you do the risk assessment, one of the biggest factors that plays a role in terms of where to place the surge protection and which ones is the actual exposed length of DC cable. However, to answer the question, also remember the actual real costly item is the inverter. That's where the sensitive electronics are. On the panel side, we find that you might lose a few bypass diodes. You know, it's a couple of $1,000 to fix or to replace a panel or two. But once you've lost an inverter, you know, that's quite a costly item. So the surge protection is primarily placed in areas where it's trying to protect the more expensive capital and more sensitive electronic equipment. That's why it would be seen often at the DC side or even in the inverter DC side. Okay?
Alexis, thanks. Last question from Anton. It says, in some countries, you need to install DC combiner boxes in a metal enclosure. And then he says, will it be applicable to South Africa?
So that's a great question. We have on the IPP level plants. So when it gets to really big plants with long cable runs and huge loops, definitely there the methodology to combat induced transients and also a topic called ground potential rise. One would have all the cabling inside a metal conduit, and this conduit would be bonded and earthed back to the earthing system. And even the tracker controllers and the combiner boxes, because you're trying to shield inside the combiner box items such as which rooftop don't have necessarily or very seldom have. Things like fiber converters, like power supplies, like string monitoring systems. All these very sensitive, you know, very expensive devices reside in the combiner boxes on the larger solar farms, but they're not yet in the rooftop space. So in a rooftop combiner box, there's not really anything sensitive electronic to protect, right? You sit with fuses and a DC isolator. If you're lucky, you might find that you have got a string monitoring system, then one would definitely protect. But the requirement from a metal enclosure for combiner box would definitely not add value yet, because there's nothing really to shield. You're shielding the cables already via the metallic conduits.
Excellent. Alexis, thank you very much. Mark responded by saying that that was a lightning quick overview. And I think that was the intention. You could spend days just going through the standards and looking at what the standard says. So this was just, the intention was to give a quick update on where the standards are and quickly answer a couple of questions. So thank you very much for the time afforded. Yeah, thanks for your presentation. We unfortunately have to move on with the program.
Good, because I have my next presentation at 11, so I also need to shoot.
Excellent. Thank you very much. Anton, your section is up next, where we are going to look at the prize giving, and I'm going to give you the floor so you can continue with that part of the presentation. Are you there?
Carel, aren't we going to give the sponsors now a time to do their presentations before we announce the prize winner?
Yes, that'll be great. Have you got the sponsors lined up? Who will be presenting first?
And we've got Herholdts.
Okay, excellent. Who would be representing Herholdts?
Jacques Olivier.
Jacques, I've just promoted you to a panelist.
Thank you, Carel. Good morning, everyone. So I'm just doing a short presentation for Herholdts. We have been in the electrical industry for almost 30 years, and we decided to expand our horizons to include renewable energy products. We sell a lot of market-leading inverters and batteries, and we also do all electrical cabling, SPDs, solar panels. We've got branches located in Bloemfontein, Kimberley, Cape Town, and George, and we consist more than 1,000 products. We can provide anything from renewable energy to electrical for commercial and household solutions. Some of the larger projects that we have done is Atlanta City, that's 1.1 megawatt hours. The UFS main campus in Bloemfontein, 1 megawatt hours, and another 750 kilowatts. At the Park Shopping Center was a 570 kilowatt project, and then various spa outlets of 500 kilowatts and more. We also have a fully functional online shopping portal. I prepared a short video to share with you guys today.
Herholdts Group has come a long way. In the last 30 years, we have grown to be the largest distributor of electrical equipment in the Free State and the Northern Cape. Starting as a family business all those years ago in Bloemfontein, we still believe in valuing our customers and staff as if they are part of our family, bringing you, South Africa and our bordering countries the best in electrical, lighting and renewable energy solutions. Over the years, we have learnt a lot about the electrical, lighting and renewable energy industry. And a lot of it is having excellent customer service. Our customers can trust us to deliver. We partner with the leading brands of electrical, lighting and renewable energy manufacturers through an extensive network of national and international suppliers. All our suppliers are selected carefully to provide our customers with only the best quality products and unique designs at competitive prices. Part of what makes us the best in our industry is that we save you time. We have branches in Bloemfontein, Kimberley and George, each delivering countrywide including Lesotho and our bordering countries, which makes distribution quick and efficient. Our well-trained and competent sales teams, which includes electricians, are seasoned professionals with many years of experience, people who understand the needs and requirements of the electrical industry in South Africa. Herholdts Group, providing you with elegant, intelligent and innovative solutions that are not only efficient but will also put the power back in your hands with leading brands at competitive prices.
Thank you, Anton. That was all for me today.
Excellent. Jacques, baie dankie. Thanks, Jacques. Anton's going to quickly announce the winners for category 2 and 3. Thanks, Anton.
Thank you for all the participants that put in submissions in. There's some awesome projects. Okay, with regards to category 2, that is for hybrid systems between 100 and basically 1,000 kilowatt peak. The second prize goes to Blockpower. Okay, it's Carel Ballack. Okay, they've done a project in Sabi Sands Creek National Park with 300 kilowatt peak off-grid system. Second prize is a SolarMD 7.4 kilowatt hour battery system and a Deltec charger. And the first prize goes to a New Southern Energy. The person there is Christina Masurek. They've done a big hybrid system with SMA and Tesla, a system in Sossusvlei Lodge in Namibia. They've got 199 kilowatt peak solar PV there with a 440 kilowatt hour Tesla battery system and a 258 kVA generator combination. They are the winners of the 50,000 Rand Herholdts voucher, a complete free assessment by Alexis Barwise from LP Concepts for Lightning. Then on category 3, that is for systems between 50 and 100 kilowatt peak. Yes, second prize there goes to Unilec. They've done a system there with 60.48 kilowatt of solar. Combination of Victron 3 15 kVA Quattros, a 20 and a 27 kilowatt Fronius with SolarMD batteries. Second prize is Imeon 3.6 hybrid inverter and a Deltec charger. The Imeon was sponsored by Herholdts, and the Deltec charger was from Deltec. The first prize is to RBN Energy, Rian Barkhuizen. They've done a medical practice in Pretoria North. That is a 94 kilowatt peak solar system with 15 kVA Victron Quattros, Fronius combination with 200 kilowatt hour Freedom 1 batteries and 150 kVA diesel generator. The first prize was sponsored by Get Off Grid, combined with Victron, and a total of 50,000 Rand voucher also from Get Off Grid and Victron. And then they also get the Deltec charger. And that is winners for category 2 and 3 then.
Wow, excellent. Thanks, Anton. We had a couple of large projects in there, and thank you very much to the sponsors who participated in category 2 and 3. Next up, I'm quickly going to do a presentation on the standards. Let me share the screen with you guys. You should be able to see my screen at the moment. Now, the standard was supposed to have been published in March of this year. So we could look at the standard and we can say, well, what's the point? Why are we even doing a presentation on the standard if it hasn't been published yet? Those of you that know me and would know that we do a lot of courses, we do a lot of presentations. And because I do a lot of courses and presentations and the interaction between industry, I get a lot of questions from installers on standards. And when this standards webinar came up, I thought, okay, well, instead of me trying to share information on a standard that hasn't been published yet and a standard that is busy going through its comment stage, I thought what I'd rather do is take the information out of the standard that is relevant and that is currently being discussed, that there are lots of questions around, and that I know is going to be included in a future standard, and we can quickly have a discussion around the different points so that you, just as confirmation of what the standard is going to cover and where the standard is heading as far as requirements are concerned. So, yes.
Sorry to interrupt, but before you start, is there any possibility we can give REVOV the speaking opportunity?
Yeah, absolutely. Is REVOV REVOV was part of the category 2 and 3.
Yes, Jon Snow, and he will be
presenting. Excellent. Excellent. Thanks, John. You know, I actually saw your hand. I actually saw your hand, and then I thought, high five. So I'll tell you what I'm going to do. Let me stop sharing quickly. It's quite interesting, the organizing a large number of guys to present. It's quite challenging. I don't think we've ever had so many speakers in one environment. So, John, there you go. You've got the floor for a couple of minutes, and then I'll take over with my presentation again.
Well, Carel, thank you so much for inviting REVOV to be part of this AREP conference, and it's an incredible webinar, and we love what you're doing. The standards around this industry are so vitally important, and we're so proud to be part of this as a sponsor and to be with you today. It's really wonderful. For those of you who don't know me, my name is Jon Snow. I'm the sales manager at REVOV. We like to think of ourselves as the fastest growing second life battery distributor in the world. In China, there's obviously China Towers, which dwarfs us slightly, but we've done an incredible job through a very dedicated team of battery enthusiasts, led obviously by Lance Dickerson, who many of you will know, and Felix. And it's so wonderful to be part of a company like that. I mean, we have a range of products which are growing every day. We've started with our 10 kilowatt hour battery pack, which is a second life battery, a very well priced, very good quality battery that has done very well in the market. We've sold over 50 megawatt hours of that battery in the last 18 months. And recently we've just brought on the market a 5 kilowatt hour battery. And we've grown our team to include a project department now, which will support any projects using containerized BESS solutions of half a megawatt and upwards, which is incredible. So we'll be able to deliver large scale solutions, microgrids and that type of thing. And already we've started engaging with various consulting engineers across the industry. And for another part of what we really believe in is the technical support of installers and people in the industry. We've got a dedicated team. Felix van Boorman, our senior technical person, director of the company, has a team across the country who's always on call supporting installations. We've got a great in-country warranty support system. And yeah, for those of you who might not yet be aware of us, I encourage you to please log into your website, go to revov.co.za, make contact with us anytime. We're a great bunch of guys. We love chatting to people about their solar projects. We're here for installers and wholesalers and distributors around the country. And we really, really love what we're seeing in the country. We love being part of it. And thank you very much, Carl, for including us this morning. We're delighted to sponsor Prize. Thank you.
Excellent, John. Thank you very much for the short presentation.
Okay.
And thanks for sponsoring the prize. Guys, I'm going to continue with the standards presentation quickly. What's of interest? So I already mentioned that the standard has gone through a couple of changes. It's gone through a commenting stage. And at the moment, one of the standards that have actually been published is the SANS 10142 Part 1. Now, it's extremely confusing because we've got lots of standards with more or less the same code descriptions. And it's kind of important to understand what it is we're talking about and what it means. So what we've got here is SANS 10142 Part 1 Edition 3. Guys, this is just the normal wiring code. And I think what I'm going to do is I'm going to increase my screen size, and then I can rather make use of my annotation tools. So SANS 10142 Part 1 Edition 3. Some of the discussions that I've had with installers has been around whether you've actually got to provide a certificate of compliance for a DC installation. And we've still got a lot of guys thinking that you actually don't need to issue a certificate of compliance for a DC installation. So I took the introduction section of the 10142 Part 1 standard. It says, in this edition, an attempt has been made to move towards the IEC codes. Guys, IEC is an International Electrotechnical Commission. So the IEC codes are international codes, primarily European. So we see a lot of European codes throughout, obviously, Europe, and we see a lot of countries in Africa adopting IEC codes. And over here, we can see that the SABS is actually busy moving towards IEC codes. So we'll see a lot of IEC codes being adopted by the SABS. And then, of course, it says over here, extra low voltage, below 50 volts, and DC applications up to 1,500 volts have been introduced as new requirements owing to the extensive usage and increased fire risk that result from high load currents. Now, although it says over here, wait, where did it say? It says, over here it says new requirements. Guys, this part of the introduction into the standard, that section of the introduction into the standard, I think has been in there for almost the last 10 years. So it's not new news, but unfortunately nobody really takes the time to read the introduction into standards. We want to get through to the juicy stuff. So there are loads of controversial issues in the existing version of the 10142 part 1 part 2, and this presentation is not going to focus on controversial stuff. I'm not going to look at spelling mistakes, errors. I'm not going to question why they added certain things into the standard. This section is going to highlight points of interest that you need to be aware of, because it's likely that this is going to be included. What we need to quickly take a look at is this section over here. So the first publication of SANS 10142 part 1 part 2 builds on SANS 10142 part 1. That's the wiring code. So the South African low voltage wiring code. Guys, low voltage, of course, is not 50 volts and below. Low voltage is below 600, what was that? 1,000 volts AC and 1,500 volts DC. So almost all your solar installations are going to be included in the wiring code. Oh, wow. Now you know. Yeah, that's funny. What this Zoom does to my cursor occasionally is it actually takes the cursor away for some reason or the other, and then I don't know where I am I don't know where the cursor is. It's very funny. In the same way that it's very funny, it's also not. There it is. Okay, let me just get rid of those annotation tools. Clear all drawings. Okay. Just a sec, guys. I'm going to go out of, I'm just going to go out of that. Otherwise, I'm going to continuously lose my cursor, and it's, I don't remember what the shortcut on the keyboard is. Obviously, yeah. So there it says, the aim of SANS 10142 part 1 part 2 is to ensure safe operation of embedded generator installations and the electrical network in its it is connected to under both normal and fault conditions. So that's the point of the standard. What is interesting is every EGI shall have a single line diagram. Guys, I get loads and loads of guys doing installations who do not know what a single line diagram is. We've got lots of solar installers doing solar installations, and they don't know what a line diagram is, and they don't know how to read them. I think everybody involved with solar installations, and certainly most of the guys that are interested in joining a webinar or session like this, wants to be able to step up the standard of solar installations. And in order to do this, we need to be responsible about our installations and ensure that we at least have a design for an installation. So the new standard is going to make it a mandatory requirement or compulsory requirement. I never know which word's the right one to use. Compulsory or mandatory. Linda usually helps me out there. To have a single line diagram. And then, of course, in section 4 of the test report. So in your solar PV test report, when you issue a certificate of compliance on your installation, one of the questions it needs to satisfy is it says, are single line diagrams displayed in the relevant distribution board? So the standard is going to make it compulsory for you to have a single line diagram of your solar installation fitted inside the DB board. I think this is a great addition. And then we've got the same image over here that Alexis showed in his presentation. And over here, Alexis also mentioned that the image has in the meantime, or the line diagram has in the meantime, been redone. So the image we see over here is not the image that is going to be included in the standard. Distribution boards. Let's see, requirements of SANS 10142 Part 1 shall apply. It says all distribution boards with an interface point shall have a single line diagram as displayed and specified in 5.2. So it defines what it should look like. And then further, it says if a single distribution board has both AC and DC, the AC and DC sections shall be mechanically separated and clearly marked to distinguish between the AC and the DC. So guys, mechanical separation is something solid, separating your AC section and your DC section, and it shall be clearly marked. So you are going to have to ensure that you've got the right labeling in there. Disconnectors. So up on the title of the slide, you see the reference of where it sits in the standard, and that reference talks about disconnectors. And over here it says, in the case where reverse power flow is anticipated, the disconnector shall be capable of normal operation in either power current direction. Now, I've got a lot of guys asking questions about DC disconnects, but they don't ever say, can this disconnect handle a reverse current flow? And I thought of including this just to raise a bit of awareness around the fact that if you are going to be fitting disconnectors, you've got to make sure that they can handle reverse power flow. PV mounting structures. The mounting structures of all PV modules shall be bonded and earthed for all installations. So there was a question earlier on when Alexis presented on bonding and earthing. And that is just, that comes out of the standard. So that should answer that question quickly. Let me just say, let's just see, Mark said something about it's a cursed cursor. A single line diagram should be the bottom line. Yes, Mark, absolutely. And then let's quickly carry on. What we've got over here, mounting structures shall be bonded and earthed for all installations. That's of course because your mounting structures are metal, so it's not really a new standard. There's nothing new about that requirement. In the past, if you had metal gutters, the metal gutters had to be bonded. Over here, overcurrent protection. So overcurrent protection for strings are required if the cable rating is less than 1.56 times the short circuit current. So overcurrent protection is required for strings when the cable rating is less than 1.56 times the short circuit current. Yeah, I needed to repeat that because sometimes these sentences are written in a way where you've almost got to reverse engineer what you are reading. So what they are saying is if your cables can handle the short circuit current, then you don't have to fit fuses. Yeah, now I'm hearing a lot of guys protesting. But wait, we'll take a look at that in a minute. Then it goes further and it says reverse current protection on the strings also required when you've got 3 or more strings in parallel. So, guys, again, the reverse current coming back into play, and over here it gives you the cable rating, and it says that if your cable rating is less than 1.56 times the short circuit current of the string, then overcurrent protection is required. I hope that makes sense. If it doesn't make sense, I'll answer a couple of questions when I am done with the presentation. When I created this presentation, I thought, geez, I'm going to be finished long before my time is due. But if I look at this, I think I might be running a little bit late. So there we go. Metal conduits. A lot of questions about metal conduits. In the previous draft, it was indicated that all DC cables should be earthed in metal conduits, and all DC cables should in fact be housed in metal conduit. But that has changed in the new standard, where it says where a system features longer DC cables, in other words, longer than 50 meters, consideration shall be given to the use of screened or armored cables or to installing the cable in earth, metal, conduit, or trunking. And then it just says in another section, it indicates, that it shall be installed in metal conduit. So there is another section in the standard where it indicates that if your cabling is longer than 15 meters, that you shall use metal conduit. You guys can prepare yourselves for this requirement. It's definitely going to be in there in one way or the other. So if you are doing larger solar installations, do yourself a favor and rather just start doing the installations with metal conduits. Guys, you are going to find if you do installations for customers and their systems are insured, the insurance is going to require the highest level or the highest standard of installation. Otherwise, they are going to throw the claim out. So when you do quotes or when you do installations and your pricing or I don't want to say the project is price sensitive, you've got to stipulate in your quotation and in your documentation that it is included or it's not included, and what the limitations of your pricing structure is. That's just to reduce your risk as a contractor or as an installer. Installer responsibility. The installer is responsible for label application based on the intended design and equipment specification. So this is fascinating because I've got a couple of slides where we look at the responsibility. Whose responsibility is it to do certain things? Because I don't know whether it's a South African thing, but we love transferring responsibility. Not my job, it's that guy's job. This slide says in section B1 and C1, the installer is responsible for label application.
Guys, just before we continue with the presentation, it's time for a quick commercial break. I want to give one of the sponsors an opportunity to quickly do their presentation, and then we'll get right back to standards. Tian from Ellies is going to do a short presentation. Tian, the floor is yours.
Ellies is a JSE-listed company with a long and illustrious history. Established in 1979, the company predominantly operated in the television and satellite spaces before expanding to the renewable energy sector in 2012. Since then, we have expanded our offering and now operate from 20 locations across Southern Africa. These locations include 6 trade counters, 9 individually run branches, 4 international branches, and 1 centralized head office in Johannesburg. These branches offer everything from wholesale solar panels, batteries, charge controllers, inverters, connectors, cable and mounting structure to solution-based offerings and services. Ellies has always strived to use local installers to ensure that local support can be offered. We are willing to provide technical support to our customers and upskill them to ensure that the highest quality of workmanship is always offered. Speaking of this, the Ellies business can be divided into 2 distinct branches. Firstly, the wholesale component, where we sell to installers who know what they need. And secondly, the complete solutions component, where we can offer the following services. Monitoring. Using specialized equipment, Ellies can offer free of charge to installers metering equipment to measure the consumption at a customer's premises. This consumption is measured in per minute data and can go up to as large as 1,200 amps per phase. This monitored data is then worked into a consumption report, which is also available free of charge to installers. We can assist the installer in the consultation process with the customer to assist them in assessing what the best system is for their needs. Ellies can also, if needed, design these systems and supply all the equipment required to get the solution from point A to point B. The Ellies offering is built around the SunSync brand, among others. What SunSync allows Ellies is competitive pricing, knowledgeable after-sales service and technical support, and a direct line to the supplier, meaning that any changes needed to the product can actually be implemented in time. SunSync is the answer to all of your needs. Not only does it combine different input sources such as the national network or a generator on the input side, it can also incorporate a wind turbine and microinverters as AC coupled systems. This allows you to set the system as a grid tied or as a UPS, or combine all of it into a hybrid, or if you really want an AC coupled system. The possibilities are endless. To us today, we can help you to stay switched on.
Excellent, Tian. Thank you very much. Let's get back to the presentation. Where were we? Bimetallic corrosion.
Bimetallic corrosion 5.4473 says a designed earth connection to the array frame. Methods to minimize the effects of corrosion shall include the use of stainless steel crimped lugs between the cable and the frame, or the use of bimetallic washers between crimped lugs and the array frame. And then it goes further to say that if the joint includes more than one type of metal, it should be sealed to prevent ingress of water using a suitable waterproof coating or taping system. Guys, we are going to see loads and loads of bimetallic corrosion issues in the solar installations, because there are lots of guys that are busy connecting a copper conductor to the aluminium frame of the solar modules. The cross-sectional area of the earthing and bonding cables of the DC installation shall be equivalent to both the cross-sectional areas of the positive and negative live conductors. So the photo on the right-hand side is not an example of a typical earthing installation. That's just meant as that's almost the lighter side of life. Guys, we've got to occasionally just look at the lighter side of life as well. We can't be too serious about everything, but earthing is relatively serious. And over here, it gives you the cross-sectional area. So getting a lot of questions on the cross-sectional area size of cabling, and this section over here says that it shall be the equivalent to both cross-sectional areas of the positive and negative live conductors. And if you look at the bonding requirements, I think it is a 6 millimeter squared cable is the smallest bonding conductor according to the standards at the moment. Protection against gassing. Yeah, I know. If you look at this photograph, we see a lot of photographs. There would be some of you guys that have fixed up a lot of installations, and maybe you've fixed up some of these installations that look like this. If you've got photos of botched installations, you're welcome to send it through to us. We use it in the training material to show guys what they should and should not be doing. And over here, it says in the standard, when determining the location and type of the protective device, any gases emitted need to be taken into consideration. The safety distance, there it says, the safety distance of 1.2 meters from the source of gas and any possible spark source shall be maintained for vented batteries. Definitely not the case in this crammed box. So that is something to take into consideration. Overcurrent protection. Overcurrent protection shall be installed for a PV string or for PV array cables when the continuous current carrying capacity of the cable is less than 1.56 times the short circuit current. That's what we saw in one of the previous slides as well. This, of course, is in a completely different section of the standard. Then it says where the overcurrent protection device is a fuse, it shall be of a type GPV. So guys, the GPV, extremely important because a GPV fuse can handle its full rated current for quite a few hours. So you can't use an AC fuse in a DC environment. And when you do solar installations, just make sure that the fuses you use are GPV rated fuses. That, of course, is also highlighted in the standard. Reverse current protection. Reverse current protection shall be installed when 3 or more strings are combined in parallel. Combined or paralleled together. So reverse current protection, that refers to fuses on both the positive and the negative side of the cables or the strings. And then it says reverse current protection can be achieved with fuses. And then again, the fuse shall be rated to be equal or greater than 1.56 times the short circuit current. And then over here, it says the applicable temperature correction factors shall be implemented. Guys, this 1.56 value actually already compensates for temperature correction. So when you see this 1.56 value, it already compensates for it. So it shouldn't be too much of a hassle. Do you guys just as a quick question, Mojalefa says that he's having an issue with the audio and that the audio is unclear. Can everybody else hear the audio fine? Are you guys fine with the way the sound is coming through? Just as long as at the moment it's fine, audio good. Clinton says fine, Richard says good, Trevor says good, sound 100%, audio fine, my sound's fine. Thanks Gerrit, thanks Eugene, thanks France. Okay, excellent. Okay guys, so if you've got audio or video issues, it may be what's the word, localized, so it's just in your area. Where do we, okay, so we've covered this slide. If we go through to the next, combiner boxes requirement. DC combiner boxes shall be required when PV subarrays are combined or where overcurrent protection and switch disconnection devices are used. Guys, so on the right-hand side, I see quite a couple of lugs that are bolted together. You're not allowed to do that anymore. And I'm not saying it has ever been a good idea. According to the standard, where it says shell, you are going to be forced to use combiner boxes. Now, my chat box says that Rian has raised his hand. Now, Rian, previously, oh, it's gone. I'm assuming you dropped your hand. Otherwise, it would have still been up there. Okay, I thought you might want to say something or ask something. Yeah, I know that looks ugly. It's a terrible connection. And we actually see a lot of these types of installations, and we are going to see more and more. Guys, of course, what's happening with this whole coronavirus is or the lockdown is a lot of guys are losing their jobs. I am expecting an influx of people that have lost their jobs to start becoming solar experts within the next couple of months. So it's good from a job creation point of view for the guys who actually know what they're doing, but it's bad from a building continuity, building trust in the technology point of view, because we're going to have a lot of upset customers because the guys that are doing installations for them, quite honestly, I think half of the guys currently doing installations don't know what they're doing. So yeah, from a market growth point of view, probably a positive to see the market growing. From a number of botched installations, anyway, there's nothing we can do about it apart from focusing on standards and promoting certain platforms with your customers. We can talk about that a little bit later. Over here it says combiner boxes that contain overcurrent switching devices shall be accessible for inspection maintenance without necessitating the dismantling of structural parts. So you've got to have your combiner box in an accessible place. And then over here it says combiner boxes shall be accessible from floor level. Guys, what this means, I've seen a couple of photographs of guys that have stuck their combiner boxes up against the ceiling. It's illegal. It's supposed to be accessible from floor level. The previous standard says that you shouldn't require a step ladder in order to access it. Combiner box is there to assist with the safety of your installation. So it has to be accessible. Installer responsibility. The installer shall confirm that the system size is approved by the utility. Whoa. Okay, so this is interesting because it's transferring the responsibility of the registration of the system to the installer. There you go, Rian. You've raised your hand again. Either that or you're playing with the controls. Rian, I'm happy to, why am I not seeing that? So normally it sends your name to the top, but for some reason or the other, Rian, it's not sending your name to the top. So Rian, I've actually activated your mic. If you want to ask a question, you're welcome to ask a question. I've activated it. You can unmute it and ask the question.
Hi, Carel.
Yes.
Just a question with regards to specifically the responsibility around the maximum size of the generator, and when will we see possibly some addition to the NRS standard with regards to storage systems, because I think that sort of adds a different dynamic than the normal grid type of system where we sort of happy to have it fixed to a certain level to get approval, but adding storage changes the dynamics quite dramatically, and maybe that's another thing to be considered on the boards at some point in time.
Rian, thank you very much. I don't know whether that was one or two questions. The one question that I got there was, when are there going to be changes to the NRS? I have absolutely no idea what the status is on the NRS standards. I used to be involved with the NRS, but I haven't been included in any of the NRS communications for quite a few years. So I don't know what the status is there. It would be possible for me to find out for you though. So if there is an interest, I'm sure I'd be able to find out and get some feedback. So your question related to battery storage within the NRS standard, if I remember that correctly. So what I'm going to do is I'll make a note. In fact, I'll just make a note on the board. NRS. I'll see if I can find some information and get you an update, Rian. So I'll let you know. I don't have an answer for you off the bat. Okay. What do we have as far as we've got one question? Do you know how or if this will be applied retrospectively? So, oh, Nick, wow, that's a good question. So, and then Nick says he believes that the NRS 097-2-1 edition 2.1 is out for final comment. So, Rian, maybe that's NRS 097. It's the 097-2-1 edition 2.1. Let's see if we can get a copy of the standard. If anybody has a copy of the standard, you're welcome to send it to me. I'll distribute it along through the group, and maybe we can. Oh, Nick says he has a copy. Nick, if you can share it, that'd be great. I'd be happy to circulate it through with all the attendees, and then maybe we can get some industry participation on that standard. I still owe you a report though. I haven't forgotten about it. Okay, guys, as far as the everybody that's registered for the presentation will be receiving a link to the video. The video is going to be on the Arab YouTube channel, so please subscribe to the Arab YouTube channel, and then you'd be able to get access there. That's going to be the fastest. We do share the information, but sometimes I'm a bit slow, to be quite honest. I don't know whether it's age related, but I find that I am getting slower and slower. I don't know whether it's the Western Cape lifestyle or the or whether it's age related, but that could be part of another discussion. Installer responsibility. So the installer shall confirm that the size is approved by the utility. Nick, I've purposefully tried to avoid your question. In fact, I forgot about it because I got carried away with the NRS standard. So Nick's question says, do you know if this standard will be applied retrospectively? So it's interesting, Nick. So guys, can people apply standards retrospectively? In the absence of standard, in the absence of a standard, it can be applied retrospectively. What it means, if you're doing an installation today, and tomorrow they approve a standard and they turn around and they say, but actually, you've got to fix up the work because it doesn't apply at the moment. So Nick, if I've got to quickly answer your question, Because of this section over here, this slide over here says extra low voltage and DC applications have been introduced as new requirements. So I personally think that when they published this, that DC applications are introduced as new requirements, the minute they published this, they effectively said that that they now have a standard for DC applications, and as long as your installation complies to this, I don't think they will be able to apply the standard retrospectively, because standards are only really applied retrospectively when you don't have an existing standard, and they create a new standard. Then they can apply it retrospectively. But if there's an existing standard and they amend it, or they bring out a new standard to support this, then all your newer installations will have to fall in line. What I would be careful of, though, is the insurance industry, because I don't know whether the insurance industry would probably be keen on applying it retrospectively. Guys, I think I'm actually running a little bit over my time. Where am I supposed to? 11:40. Yeah, so I am a little bit behind. I'm going to try and finish this. Oh wow. Okay. Going to try and run through this quickly so that Anton can finish the last section of his prize giving. So the EGI installer, so it becomes the installer's responsibility that the PV modules are secured to an applicable structure, considering wind speed. Yes, there it is. That's the part I wanted to focus on, considering wind speed. So guys, installers are going to get a whole lot of additional responsibilities. And wind speed is one of them. Certification for salt mist corrosion shall be considered for PV modules used in coastal areas or for maritime applications. And then certification as per that IEC standard shall be considered for modules installed in wet, highly corrosive or agricultural environments. So you guys have got to make sure when you do installations and you pick a solar brand, a solar panel or solar module brand, you've got to make sure that the panel is applicable for that particular environment or that particular installation. We tend to think of a specific brand, we like that brand, and we stick to it regardless of what we do, because we do installations all over. And we've actually got to take into consideration that there are different types of modules for different applications.
Okay guys, the next slide coming up is maintenance, but before we get through to maintenance, I just want to give the guys from SolarMD a quick opportunity to tell us a little bit more about themselves. Lenny, you're welcome to continue with your presentation.
Hi there, my name is Leonidas Hanos and I'm the Head of Technical Support at SolarMD. I know most of you know SolarMD and our range of products, but I would just like to give everyone a brief overview of who we are. SolarMD was founded in 2014 with a vision of empowering developing markets through battery storage and changing the way these markets utilize and monitor energy. The way we wanted to achieve this was by making our products beautifully designed, simple to use, robust, modular, and by providing an elegant user interface that was easy to understand. SolarMD is the only approved CATL integrator in Africa. We have a manufacturing capacity of 250 megawatt hours a year. This is achieved at our 10,000 square meter manufacturing facility in Montague Gardens, Cape Town. SolarMD is dedicated to empowering people through the latest technological advances in the field of energy storage and by revolutionizing the way man monitors and utilizes energy. SolarMD has tested our batteries in 700 real scenarios across Africa in 2 years, from 2014 to 2016, before we offered our final products to the market. This has served as a benchmark for the development of our products, as our engineers designed the product to not only be robust and aesthetically pleasing, but to be easy to install as well as modular and future-proof. We developed our own BMS. Our hardware and software engineers could define the exact functionality of the BMS to optimize our offering for the demands of the African market. This includes over-the-air firmware and software updates, which allows us flexible and almost project-specific problem solving. We currently monitor over 6,000 live systems across Africa through the MyPower24 portal. Designing a solution from scratch was a great opportunity for us to provide the market with everything it needed and to solve the issues that earlier lithium solutions brought to the market. And this is exactly what we have done. Thanks to everyone for being here and everyone that utilizes our products. Thanks to everyone that is considering utilizing our products in future projects. Cheers.
Excellent. Thank you very much, Lenny. Thanks for your presentation, and thanks for SolarMD for being part of the competition.
So then, maintenance. The customer is responsible for ensuring that the embedded generator is maintained. Okay, that's interesting. So the customer is responsible for ensuring that the embedded generator is maintained. And then it goes further to say that embedded generator systems shall have planned maintenance to ensure the safe use of the installation. Guys, this is amazing from a maintenance point of view, because this is going to, first of all, give you guys continuous work, because you'll be able to go back. Customers are going to be forced to enter into maintenance agreements, which I personally think is amazing, because it's going to reduce the risk of electrical fire and faults. And then it says the operation and maintenance manual shall be provided to the customer and owner of the EGI. So this is the installer's responsibility. So it's the responsibility of the installer to provide the customer with the necessary documentation. Where batteries are used, protection devices and conductors should be suitable for the short circuit current rating. This is interesting. So over here, of course, we are talking about that Ka rating. On the fuse in the image, we've got 120 Ka rating. And yes, this is where you see the 500 volts, you can see that you can see the sine wave. We have sent an email to the guys from this particular brand, by the way. And I know it's no name brand because I took the brand name away. I thought it's not a marketing initiative. We've sent them an email and we said, we see that your fuses are AC rated, and they replied via email and said that their technical department has approved these fuses for the DC environment, even though it's just got an AC rating. We haven't received any other written confirmation as to exactly what the specs are if you use this fuse in a DC environment, but yeah, that's just as a matter of interest. What's interesting here is where batteries are used, protection devices and conductors should be suitable for the short circuit current rating. Fascinating stuff. So you've got to make sure that your conductors can not only handle the current rating, it's designed by you to be able to handle the fault current rating. Guys, there's a reason why we pay engineers to assist with designs, and this would typically be where you would get an engineer involved. Nick says, I believe the same is true for most of these fuses, but with a limited voltage rating, I've seen them DC rated up to about 60 volts or so on some of them. Yes, yes, Nick, of course. That is quite correct. Thanks for the input. Oh, wow. It is recommended that the embedded generator designer does basic power quality measurements. Wow, look at what this is adding: power factor, harmonic content, and load balancing in case of three-phase supply. So we are building a breed of electricians that are going to be forced to become more professional and have a higher quality tools to their at their disposal. So suppliers, of which Nick is one of them, could be looking forward to a whole lot of demand on power quality testing equipment. So of the present utility power supply prior to the installation, this is part of the top sentence. So such as power factor, harmonic, load balancing of the present utility power supply prior to the installation. This is to be done so that you can identify issues and then address them, and then even compare them after the installation. This is just what I would consider to be good practice. So it's just something that you've got to do in any case. I just see that it's being built into the standard. So each PV string shall be numbered on the cables and on the panel. And then it goes further to say, example, on the panel on the roof, on the cable at the inverter, and on the combiner box by a suitable identification system. So you want to be able, if you do an installation and you get hit by a bus, you want to be able to leave your installation in such a way that someone else knows what's going on in your installation. Of course, those labelings would coincide possibly with the labeling in the line diagrams and the drawings that you've left in the DB board. Where the terminals of a disconnector may be energized in the open position, such as the panel protection fuse, a label shall be mounted adjacent to the device indicating such. So, and then I've left the label on the right-hand side over here. That's what the label looks like in the standards. Then it goes further to say, when equipment is energized from more than one source, the isolation means shall be grouped, identified, and labeled using a label such as shown as in figure C8, which is C8 is what I've got at the bottom over here, where it says photovoltaic, that white label over there. And then it says the white middle portion of each label shall be used to print isolation means or series. Yeah, so that is interesting. The solar PV DC circuits that are hidden under buildup, laminate, or other materials shall be indicated and marked with this type of label we've got over here. So when you're running solar cables underneath a roof, a roofing sheet, for example, and you can't access it from anywhere, you're going to have a warning sticker up there indicating that you've actually got cables running underneath it. Then electrical metallic tubing, conduit, and or cableway shall be marked by a label, such as the one shown here, in no less than every 3 meters at every turn and above and below penetrations. Yeah, that's excellent. So on a commercial installation, of course, this is general practice, but we need to start pulling the best practice from commercial installations into residential installations so that it becomes more obvious where your cables are running and what the cables are and where they are going. So Guys, that brings me to the end of this presentation. Next up is Anton, quickly going to do the prize giving for range 4 and 5. And we are going to have 1 or 2 more presentations. I don't know whether there are any final questions before I move on. There's a guy by the name of Jagadisan from Botswana requesting a copy of the presentation. Jagadisan, it's fine. I will, as long as you've signed in with that particular email address, you'll find it. So I'm just going to type here. I'm going to type in the message because I've got to type something to get the message to go away. I'm just going to type it's on its way. You would know that it's not, but it will be circulated as soon as we circulate the video, as soon as we've had that uploaded. Anton, are you there?
Carel?
Yes, Linda.
Thank you. Carel, if we do have Ellies, Gary Gillingham from Ellies, Kalayan from SolarMD, and Scott Andrew from Get Off Solar.
Okay.
If they are part of the presentation, if they could just raise their hand so that we can elevate their status so that they could present, because they are of the sponsors.
Excellent, Linda. Thank you very much. I do recall having seen Gary earlier on, but I see that Gary is not in the presentation at the moment. Who are the other guys?
Kalayan from SolarMD.
Kalayan, I looked for him earlier on. He wasn't.
He's not on.
Okay, Anton says he's not
on.
on.
We've got also Paul from Paul Sherrat from Full Circle Solar. He said that he would do a presentation, Linda.
Yes, I have elevated Deltec. Our sponsors that will be presenting now will be Deltec. It is Carl Luther. We have Full Circle Solar, Paul Sherrat, and then Carel will also speak on behalf of PQRS, as PQRS has also sponsored a prize. Alexis Barwise from LP Concepts with the Earthing and Lightning had to take a call, so he won't be presenting on behalf of LPC, but just to remind everybody that LPC and PQRS will be having an Earthing and Lightning course on the 14th of August. So Carel, please, Carl Luther, if you can just allow him status to share screen, please.
You should be able to share your screen.
Right, good morning everybody, and thanks so far, Carl. It's been very interesting, your presentation. A lot of information. I've been wondering what's going to happen. You've answered a lot of questions. I'm not going to do a presentation for you guys. I just want to talk to you and tell us a little bit more about us, because I've only got 3 minutes to talk. And Deltec is a battery wholesale company with a national footprint in South Africa. So what we really do is we import batteries from all over the world, from all continents, from the United States, from Europe, from India, a little bit from China, South Korea, and we warehouse the batteries and we distribute them. What do we bring in? We bring in batteries that our customers need. So we don't just bring in what we think you need, we bring in what you ask us to bring in. So if you've got a need for a specific product and you need somebody bring it in and warehouse it for you so that it's available for you when you need it for installations, we're happy to do that. We facilitate getting the product here. We facilitate the warranties if there's any warranty issues, and we facilitate obviously getting the batteries delivered to site. So we've got a fleet of vehicles that can deliver anywhere in South Africa. We've got a branch in Johannesburg, Cape Town, Durban, Rustenburg, which is on the Platinum Mining Belt, and Nelspruit, which is strategically positioned for Mozambique and for installations in the Kruger National Park, where we're very busy. So we can assist people with product there. Our main core business has always been lead acid batteries. So Deltec was established in 1979 and has been providing batteries and battery-related products all through South Africa since then. The company's grown quite a lot in the last 5 years, and we are now also starting to move into the lithium space, but traditionally still a lead-acid battery product provider. What's important to know about batteries is that batteries are specifically made for specific applications. So you can't just put any battery into any application. And what we provide as a service is to assist people to understand how batteries work. And if anybody needs a presentation on how batteries work and how to size them and why you're choosing specific technologies over other, I'm happy to be part of that. So you must be very careful when you purchase a battery. AGM batteries are designed for specific applications. Gel batteries are designed for specific applications. Vented batteries are designed for specific applications. People will tell you that lithium batteries will outlast lead acid batteries in installation. It's not a true statement. Lead acid battery will give you the same life as a lithium battery if you choose the right lead acid battery, but there's only few of them. So if you choose industrial lead acid batteries, you'll get 10 to 15 years life out of them. But if you choose a cheap AGM battery, you're going to get 1 year out of it because it's only designed to do 500 cycles. We can assist you there. So that's what we do. So we can also assist you if you've got battery problems. Let's assume you've got installations and the batteries aren't delivering the kilowatt hours that you expect, and you're battling with that. We can assist you to try and fault find and trace why it's happening and help you to rectify it. That's part of the stuff that we do. Something I'd like to add is that every battery has got a threshold, and you have to use that battery within the design thresholds or you're going to lose it prematurely. It's not the battery's fault. It's because the battery hasn't been used correctly. What's important to know is a battery is not a fuel tank. It's not a diesel tank that you fill up with diesel or a gas bottle that you fill up and you use it as you wish. You've got to fill it in a very specific manner, and you've got to discharge it within the thresholds that it's designed. Otherwise, it's going to fail prematurely. But if you work within the thresholds, the batteries actually last. We've got lots of lead acid applications that are way in excess of 10 years that still deliver full capacity. But we also believe that the lithium market is at a point of tipping that we're going to move. So we're starting to move into the market as well. And if you've got needs for lithium batteries, we do have a little bit in stock at the moment, and we will be going in the last quarter of this year. We will be stocking up with a lot more different types of products. But if you need anything, we can bring it in for you. We land containers on a daily basis and warehouse and distribute all over the country. And we want to stock what you want. We don't want to just stock what we think you want. So if you tell us what you want, we'll stock it for you. What's very important to understand about a battery, the biggest killer of batteries in energy storage systems is a thing called partial charging. So try and avoid that at all costs. And what it really means is if you don't bring your battery to top of charge, I'm talking on lead acid batteries, you can't balance the set on a regular basis. And it results in partial charging. And that is the biggest killer of all batteries. It will even kill a lithium iron phosphate battery. And that's why they have to have the BMSs. So guys, that's really what we do. We also do obviously charging equipment for all the different applications. So we've got batteries, charging equipment. We tier 1 distributors for Victron equipment. And we also do Stecker equipment. So if you need us to help you, please, I'm sure they will distribute our email address. You can contact us and we'll assist wherever we can. And we are passionate about the renewable energy industry and we'd love to help wherever we can. Thank you for the time. Appreciate it very much and enjoy the prizes.
Excellent, Carl. Thank you very much. Thanks for your 2 or 3 minute slot. Might have been a 4 or 5 minute slot. I wasn't watching. Paul, are you available? I can see you. I can see you in the panelist box. Is your mic up and running?
Hi, can you hear me there?
Yes, you're welcome to take the floor. Thank you very much.
And can you see the share screen?
Yes.
Okay, we'll see why this is not. All right, morning everyone. Just give a short presentation on what we're doing as we're one of the sponsors for one of the prizes. So my company is called Full Circle Solar. We supply mainly to residential installations. We've been around since 2015, and we started importing the Expert range of inverters from Voltronic. We also do solar panels and batteries, sorry, spelling mistake there. And basically, we haven't ventured into any other different brands and that. Reason being is we believe that we stick to what we know and we can support it well. And we can give full service backup, etc., whatever is needed for those products. We're targeting mainly via our website and our walk-in shop, and we distribute them to most electricians, solar shops, and solar installers. We currently have distributors around all of Southern Africa. We go up as far as Zambia, Malawi, and we've even got a few customers in the DRC and up in Nigeria. We're starting now with a couple of business distributors, so you can find our products in the companies based in Mossel Bay in the Volt Triangle, and we also have an agent now based in Malawi. Products that we supply is obviously the Voltronic inverters. We're also delving now into the Huawei grid tie systems for small to medium installations in a lot of businesses and factories. We sell mainly the Narada and the Pylontech lithium batteries, focused on mainly Canadian JA and Cinco solar panels. We do our own cabinet design and manufacture our own cabinets locally. We do a range of solar and LED lights that can be seen on our website. And we build our own combiner boxes and AC boxes to suit our installations and our products. We've also started delving into some plug-and-play systems, particularly on the 1 kilowatt, 3 kilowatt, and 5 kilowatt range. And we're also able to do repairs on most of the Expert and Infinity Solar range of inverters.
Paul, thank you very much. Thank you very much for the presentation. And I think Anton will be up next. Anton, are you there?
I'm online, thank you, Carel.
Excellent. Would you be able to, you've also sponsored a prize, if you can give us just a quick brief introduction of Off-Grid Technologies, and then if you could announce the next prize winners, that would be great.
Okay, Carel, thank you. First of all, I would like to thank REVOV, Carel, Linda, Petru, and everybody that was involved making this hybrid competition a success, and with all the help. And thank you to all the sponsors. The prizes was awesome. Then I would like to thank all the companies that have submitted their entries into the competition. I would like in the next year to receive much more entries. I think it is beneficial to the industry that we are doing this type of competition to ensure that we get better installation and that the installers is proud of their work. And with the REP certificate for the competition, they will be able to show it also to their customers and tell them, you know, we are a good company. We really know what we do. Okay, so like I said, on category 4, the third prize goes to Solarite. Okay, and Solarite had a system with 11.6 kilowatt solar with Fronius inverters and Victron Quattros and Freedom 1 batteries. And the sponsors for that groups on the third prize was a PQRS course that was sponsored by PQRS and a Deltec charger by Deltec. The second prize to go to a Hawk Solar. Hawk Solar, Martin Ferreira, they've got a 10.95 kilowatt peak system with the JA solar panels, and it's a complete SMA hybrid system with SMA Sunny Islands and Sunny Boy. Okay. The second prize to Hawk Solar was Ineon 3.6 hybrid inverter that was sponsored by Herholdts and the Deltec charger. And the first prize go to Specialized Solar Systems. Specialized Solar Systems, they had quite a nice system, also with 19.8 kilowatt of solar and a Victron hybrid system. The first prize was a REVOV 10 kilowatt hour battery sponsored by REVOV and Ellies SunSync 5 kilowatt hybrid inverter. Category 5. The second prize there went to Go Solar, that is Werner Pagels. He had a 7.54 kilowatt solar system combined with a SolarEdge grid tie inverter and a 5 kilowatt Goodway hybrid inverter and a BYD battery bank. The second prize to Go Solar was a Ineon 3.6 hybrid inverter that was sponsored by Herholdts and the Deltec charger sponsored by Deltec. And the first prize here goes to Sunor, that is Sofia Norkia. They had a solar system of 8.1 kilowatt with a Goodway 10 kilowatt hybrid inverter, 20 kilowatt hours of Bijl batteries. And the first prize to Sunor Energy was a 3.7 kilowatt hour SolarMD battery from SolarMD and a 5 kilowatt expert hybrid inverter sponsored by Full Circle Solar. So that's all great prizes, and I want to congratulate all this entries. It was quite good. I would also like to thank you all the judges that have participated in this. It is industry guys. I don't think I have to name them, but it was independent guys that have went through all the submissions, and I thank you for all their hard work also. I think that from my side.
Anton, thank you very much. Guys, that more or less wraps up the program for today. We've got Greg Blanford. Greg, are you there?
I've been listening with half an ear because I've been in so many meetings this morning. So yeah, welcome to everybody. I'm just going to switch my video on again.
Excellent. Thank you very much. Greg, the last couple of minutes, they're all yours.
No, thanks very much. Yeah, so guys, well done on this discussion today. It was very, very insightful from my side. For all the participants today, well done to you, the panelists, etc. Yeah, and also just well done to AREP for hosting such an important event, and for all of the manufacturers, the distributors, and also the industry stakeholders. And a very special thanks to Carel, who's the president of AREP, and to Alexis Barwise, the director of LP Concepts, for the presentations on the new standards. I think when it comes to the standards, I think everybody's been anticipating the rollout of these standards. And let's hope, yes, as the comments a bit earlier in the conversations, that these things are not going to be implemented retrospectively because they could cause some issues. But anyway, we'll see. Also, just a very, very special thanks to Anton de Swart, who's the chair of the AREP SSEG committee and the director of Off-Grid Technologies, also for organizing the hybrid competition with AREP and then securing such tremendous prizes. And again, thank you very much for all of those prizes to all of the contributors. So I think, I mean, in general, this type of competition and the nature of this type of competition for the industry is very important because it brings a focus on the installation standards and the products being utilized in the South African market. And I'm also pleased to see, you know, the initiatives by a lot of the manufacturers and local distributors in bringing a lot of these products into South Africa, and also local manufacturers of these products. So very well done to you. As far as the sponsors are concerned, I'd also like to congratulate you guys for coming on board with AREP, and then also to all the winners of the prizes. Congratulations to you. And then a very, very big thank you to Linda and MK, the exco of the AREP committee, and then Carel especially. So Carel's also got a nickname, Mr. Wonderful. I'd just like to, very, very special thanks to you, Carel. Yeah, I mean, as I say, I know all the work that goes on in the background, especially with you know, with when things come to standards and putting together course material and et cetera, and I just like, from my side, just like to thank you very much. It's a very much needed course, and also pass on all this information to industry. I think it's vital. So very much thank you, Mr. Wonderful, for that, and then also again to Linda, also sitting in the background there, for all your hard work. It's very, very much appreciated. So yeah, guys, excellent. Not much more to say from my side, except again, very much a big thank you to everybody who participated today in the event. Yeah, and I'm sure we'll have something like this in the near future again.
Guys, thank you all for joining us. I think I'm going to close the session. Thanks for taking the time, and I hope you got some value out of the information that was shared here today.
Thank you.
Bye. Bye.
Thanks all.